back?
Maybe.
Okay.
Yes, no, maybe.
I think so. So everybody put away your books or your whiteboards that you're working on and get out your math workbooks, please. Alright, does everybody have them out? Okay, cool. Class? Okay. My limit on classes today is 4. I don't want to do that a whole bunch. I'm not really feeling it. You cool with that, 4th graders? Okay. So today we are going to be talking about real world problems involving fractions. Now before we start with our true and false, I want to page you guys and see if anybody can come up with a real life scenario where we would be using fractions. Quiet hands only. Braden. Building, like what?
Houses.
Building houses? How? How would that be a fraction? Elaborate.
Size of wood.
Okay. Perfect amount of parts of wood to make
Yeah.
a whole house, maybe. Okay, Ellie. Baking. Okay. Elaborate. Explain. You're using parts of a whole cup to measure what you're putting in your cupcakes or your cake or your peanut butter pie or whatever.
Maybe like clothes or something.
Clothes. Explain that one.
Because you have to write a fraction, maybe like, oh, this should be this size or this should be that size.
Okay, I like it. All right, I'm going to put up a problem on the board, and I want you guys to think about it for about 33 seconds.
Yeah.
Okay, think about it, and then raise a quiet hand when you think you can tell me whether this is true or false.
Jack, I don't know if you guys are going quite yet, honey. Sarah, just hang tight. they're doing on a roll.
All right, everybody have enough time to look at that?
Yep.
Okay. Parker, I saw your hand first. Tell me if it's true or false. False? Okay. Can you explain to me why you think it's false? With words, please, preferably.
3 plus 2 plus 1 equals 6. Not 6, so then it would be 6 tenths.
6 tenths. And how many tenths do we need to make a whole? 10 tenths, right? So, when we're adding to make a whole, we need as many parts as we have for our denominator, okay? So we only have 6 up top, we have 10 on our denominator, so that means that we know that 6 tenths is not 10 tenths, which does not make it a whole. That was a long-winded way of saying it's not a whole. Does that make sense to everybody? Okay, thumbs up if it made sense. Cool. That might be my coffee. Cool. Okay, look at this one. And this time when you're ready, I want you to stick out your tongue. Quietly stick out your tongue. Okay, who wants to raise a hand and volunteer and answer? Brinley.
I think it's true because 3 plus 4 equals 7, so that'd be 7 tenths.
Mm-hmm.
7/10 is equal to that.
Right, so we can basically swap out this 10 for this 1, right? They mean the exact same thing. Okay? And then when we combine the 3 and the 4, the 3/4 and the 10/4, then we get our 7/4, or our 7/10, sorry. So these both equal 17/10 overall. Cool, Sela, got something to add? Okay, cool, I was just checking. Still making sense, everybody?
Yeah.
Okay. All right. I'm only going to give you guys like 15 seconds. Let's do rock on with the tongue out when you're ready for this one. All right. Oh, and what do you think? False. Why is it false? Yep. So I think it's trying to trick you up by thinking that this might be 1/10, right? And then you're just going to add your 1 to your 5 to get the 6/10. But we know that a 1, if we were going to write 1 as a fraction in tenths, what would it look like? Which one of these fractions would it look like? 10/10, right? So we would really be adding 5/10 to 10/10, which would equal 15/10. Okay? Last one before we move on to something different. Probably. Okay. Okay, this one's a little trickier. Rolling.
It's true. Because it would be the 2/10 plus 10/10 equals 1. This 10/10 is 1/4. 2/10 is equal to 1/5. Because 1/5 times 2 is
Okay, does everybody agree? Does anybody have a different thought? Parker?
I don't know what you said, but 2/10 plus 10/10 is 1 whole and 2/10, and then 1 plus 1/5 is 1 whole and 1/5, and then 5 times 2 equals 10, and 1 times 2 equals 2.
Sure. Yeah, that's basically what Roland said. So what we need to do to figure this one out is we need to make our 1/5 into a tenth, and we do that by multiplying the top and the bottom by 2, right, to get to tenths. So then that equals 2/10 plus 1, and we know our 10/10 is a 1, so we have 1 plus 2/10 and 1 plus 2/10. Following?
Yeah.
Big thumbs up if you're following. I'm seeing a lot of little thumbs up out there. Get them way up in the sky, people. Okay, coolio.
Oh, there it is.
Okay, we're going full screen, I guess. Okay. So think about this for a second. I'm gonna give you guys a minute. How can you explain your answers without determining the values of both sides? So think about that for a second. All right, who wants to take a crack at that one? Sela?
Has anybody answered them?
Sure. I like thinking outside of the box, but that's not the answer I'm looking for. James?
Like of all? Like every single one?
I mean, it can't apply to every single one, but you can pick just one if you want to.
The one below,
Which one?
the one below.
Okay. How would you do that?
I'll do it by like 5/10 is the one, but it doesn't go onto the last one. It's like 1/3, and then I'll just add the 6 to the top. And
Sure.
the 10 stays the same.
Okay. I like that thought, James. Anybody else? Okay. So how I would do it without determining the value of both sides is if I see a 1 on one side and then something that's not a whole on the other side, do we already know those aren't equal?
Yeah.
Everybody shake their heads and nod. We know they're not equal, okay? Because if there is a fraction of a hole on this side and we have a hole on this side, they can't be equal because one's already going to be smaller. Make sense? Make a lot of sense or little sense? Okay. I'll come around and try and explain that in a different way when we're working on other things. Okay. So on page 189, page 189, you are going to complete problems 1 and 2 independently, and then complete problem 3 as a partner. Can I trust you guys to choose your own partners?
Yes.
Okay. Yeah, just work with your neighbor right next to you. I don't want you guys moving the time. But hey, class.
Yes.
That's 2. How many left do we have? 2 left. Okay. When you're working on these independently, should I hear any talking? No, because you are working hard and quietly. When you're working with your partner, you can use whisper voice. I don't care. But solve those first 2 problems, and then we will talk about them on the board.
Well, that was funny. Yeah, I spent a lot of time thinking about it. Maybe we'll lay back down. Or lay back out. You know what I mean? Okay, yeah, sounds good. Guys, I don't think you're leaving yet. You came in and did not tell me to send you, so just wait. Okay? Sarah, we will, well, I guess she'll send it out to you.
She's not just, hey, yes.
If you go with Mr. Carlson, this is everybody today that goes with him, since you missed yesterday.
Yeah.
ready for them. I've been kind of holding them back, but then Jack escaped when my alarm went off.
Yeah, no, that's,
Okay,
we're ready.
they're ready.
We're ready, yeah.
What?
Thank you though.
Need help?
Or, and was oblivion. I love that. I do. Yes, I love that.
Okay. I'll probably explain what we're doing on board, okay? So, if you didn't get it, we're gonna talk about it right now, so don't stress. Miss Dunster, do you care if I use a whiteboard?
No, not at all. Whatever you need or want to do.
Okay, everybody eyes up here on the whiteboard. What? Just a small portion.
No,
Maybe
he,
part of
I
the
forgot.
whole.
I forgot to tell him he is teaching.
I probably figured it out. Okay, so, can somebody read problem 1 to me? I already forgot.
Can I?
Elise.
Last week, Henry gave Benny the following amount of water. Monday, 3 tenths cups. Wednesday, 6 tenths cups. And then Sunday, 7 tenths.
Okay. So, if I was going to draw this, how would I do it? Siva.
So you, what I did was, I made 10, so I did like
Rectangle? Yep, because we don't need 10 lines, because that would make it 11s, right? I'm not an artist, do not judge my work.
Trust me, mine is
Okay.
worse.
So, did you just draw one of these?
No, I had to draw 2.
You had to draw 2, but did you draw 2 right away? Or did you start adding first?
So it's not
Okay, so let's start adding. What did we get on Monday? How many tenths?
3.
So how many of these parts should I fill in?
3.
Right? I'm just gonna put X's in them. You guys can shade them in, do whatever you want.
I just do
Okay, how many did we get on Wednesday?
6.
6. Okay. So how many parts of the whole do we have right now?
We only have, one more.
9 tenths, okay? Now we have to add 7. So is that gonna fit in just this one? No, so should I draw another rectangle? Yeah. Okay, so I'm gonna draw another rectangle with 10 parts. Okay, so now, do I start just filling in this rectangle?
No, you finished the other rectangle.
I have to finish the other rectangle first, so I have 1, 2, 3, 4, 5, 6, 7. Okay. So, how do I finish this? How do I get my answer?
You do.
Owen. So what does this work? In terms of tenths? How many tenths? 10. Okay. So there's no way we know we have 10 over here. Okay, and how many is this one? 6. So we add 10 plus 6. 16. Is it just 16 or do I have to add something else to this answer?
1 and 1 is 6. 1 and 1.
16 tenths. And then if I was going to write it as a mixed number, I would write 1, 6 tenths. Anybody try and simplify this, Brad?
No.
Great. What's up?
3 plus 6.
Where are you getting 3 plus 6 from? Oh, for the equation? Yeah, so your equation, what we'll do, I'm just going to erase the days of the week here. You just write plus, plus, equals,
And so I would, yes, I would.
okay,
Most right.
that makes sense. Okay, actually, or are you lying to me to make me feel better?
We're making.
No.
Okay, let's do number 2. Who wants to read number 2 for me?
Man, please.
Okay, thank you for raising a quiet hand and not begging to read the problem. Okay, so do we want to start with an equation or do we want to start with drawing?
Drawing.
Nice, I like that answer a lot, 4th graders. Okay. So, Walker, what did you do?
So I drew 2 rectangles because there's 2 holes.
Okay, you drew 2 rectangles because there's 2 holes. Okay, how many pieces did you put in each of those rectangles? 6. Okay. So how many lines do I need? 5. 1, 2, 3, 4, 5. Okay. Same thing on the bottom? Okay. That does not look good. Okay. Then what'd you do?
And then I colored them in.
Like all of them?
Yeah, so and then
Okay. So what does this represent, Walker? 2 holes. Because in the problem we have 2 feet of ribbon, correct?
Yes.
Okay. So how many parts of the hole are we taking away?
5.
Right answer. Right answer. Owen? 5. Okay. So I'm erasing 5 X's, right?
Yes.
That check out, everybody?
Yes.
Okay. Okay. Sorry for the lazy eraser job.
It's fine. I suck at it.
Okay, so how many parts do I have left over, 4th graders? Show me with a quiet hand. Braden?
5, 6, 7.
Okay, we have 7 pieces left over, okay? So, do you guys want to write this as a fraction or as a mixed number?
Mixed number.
Okay, thumbs up for a mixed number. Thumbs down for fraction. Okay, that was pretty split. We're just gonna do mixed numbers though, because I think it's easier out of this. Because we already know we have what right here. What does this represent? A hole. So that means that this is our 1. And then we're counting in sixths. I'm so bad at saying fractions. Sixths. Okay, and how many sixths do I have? 1, okay?
1 and 1.
So 1 and 1/6. Okay, so we know how we're going to write that as a mixed number with our model. How would we write an equation for that? Who wants to take that challenge on? Siva?
Me.
I'll get you next time.
I would do
2 minus 5 sixths equals 1 and 1/6. Okay, that was a lot. Are we cool? We're making it? Everybody still there? Doesn't look like anybody's asleep yet, so that's a good sign.
Can I do equation? Can I say equation?
Do you do it differently?
Yeah.
Okay, what'd you do?
So I did the 2 holes minus 5 equals 5 6, and then 5 6
That's fine.
my brain is confused.
All right.
I'm tired. I want to go to bed.
Me too, man. Me too. But we gotta be
Since
strong.
you're the teacher, and you can just let us go.
I am the interim teacher and I can't make decisions like that. That's what in my head.
Huh? Then just jump.
That was a lot of business jargon.
Even after this lunch.
Okay. So we just solved it in the obvious way on the whiteboard. Are there any other ways you might want to try model-wise next time? James,
The other way is like fractions.
like just the equation instead of, yeah. I like doing just the equation, but some people like visualizing more. Are we cool with rectangles?
Yeah.
It doesn't need to be a circle on this one, does
No.
it? Yeah.
Only if it's a pizza.
Only if it's pizza or a cake or a pie or a cookie, right?
Or a chicken nugget.
Wait, my head's
Okay, we're gonna move on.
Let's go.
or
We still have an hour.
Still having, cool.
So 30 minutes, I mean.
Okay.
30 minutes.
Class.
Yes.
Okay, that one doesn't count. I was also distracted and I was distracted. But now we're back. Eyes up here. Locked in. Okay. When you have a story problem involving addition or subtraction of fractions, you can use a visual model to represent the situation and solve the problem. Do we all understand that?
Yeah.
Okay, do we all understand how to do that?
Yeah.
Okay,
Yes.
cool, nice. Okay, so with your partner, I want you to work on problems 4 and 6. And then, hey, have good answers, because we're gonna, 4, 5, and 6, sorry. We're gonna talk about them afterwards.